All right, so here we are, assignment 4.1, beginning of unit 4. You've already seen the lesson and wrote down your notes for the lesson. So this assignment is about absolute maximum, absolute minimum, the mean value theorem. We're going to practice right now together so we understand what those mean. And so there is some vocabulary here that we need to understand. So when we get to it, we'll go over it. So as you can see on the screen here, you see assignment 4.1. It says use the graph to the right and then write down what is the absolute maximum value. So what does that mean? So absolute maximum value is the highest y-coordinate or the greatest y-coordinate and only the y-coordinate. So you need to write on your answer document assignment 4.1, and then I have that here too when I put on my hover cam. But looking here, what is the absolute maximum value, the highest y-coordinate? And the answer is, if you look at it, it's 3. So positive 3 is the greatest y-coordinate. At what point does the function reach a global minimum? So the word absolute and the word global mean exactly the same thing. So they're saying the same question, but this time the word minimum, and again it's looking for this time the point, but it has to say specifically once the point, and if it didn't say the point, if it just said global minimum, then it would be the y-coordinate again. So where is the global minimum? The lowest point on the graph that you see. And so you can see that is at the point, what, 5, -2. So at 5, -2 is the global minimum, and it's a point because it asks us for a point. Number 3, at what x value or values does it have a relative minimum? So now we're just looking for the x-coordinate. So for the x-coordinate where there's a relative minimum, the word understanding of a relative minimum or a relative maximum is that it's the lowest or the highest point in its area, meaning I need to have points to the left and to the right that are either higher or lower than it to make it that. So for this, for a relative minimum, one x value is when x equals 0. When x equals 0, there's a minimum, and exactly directly to the left and to the right, there are higher points in it. So it's its lowest point in its area. Where else is there a minimum? Now this one's a little bit challenging. The one that's not challenging is 5. So when x equals 5, you can see there's a minimum. But at 4, why is it at x equals 4 is there a relative minimum? And the answer is that point at 4, directly to the right and left, immediately, it is the lowest point in its area. And that's what makes it a minimum. So what are the x values? 0, 5, and 4. Question number 4, again, it says, what are the x values or value where the function has a relative maximum? So I'm not looking at the end points because we need points to the surrounding it, to the left and to the right. And so an end point doesn't qualify for a relative. An endpoint could be a global or an absolute, but not a relative maximum. So we have a relative maximum when x equals 1, and that is the only one. So let me show you in terms of what I've written down so far. So for assignment 4.1, number 1 answer was 3, the point, 5, -2, the x value, and the x value. So that's where we're at so far. So if we're looking off a graph, I'm just going to show you the graph and talk through it, and then I'll show you what I wrote down too. Let's see. Number 5. So in number 5, it says find the critical numbers of these functions. So it's y equals x squared subtract 3x. We're going. So first of all, what is a critical number in calculus? And a critical number is one where you take the first derivative, and it's what values make the first derivative equal to 0, or what values make the first derivative undefined. So we're going to look at both scenarios. So number 5, I'm going to write it down and then I'm going to show you my work. So y equals x squared subtract 3x. So first step is to take the derivative, simple power rule. That's 2x subtract 3. So I'm actually going to look to see, is there anything here that would make it undefined? And the answer is no. It's linear. Every value for x works, so there's nothing that's undefined. Next, we make it equal to 0 and solve it. So to solve for x here, you would add 3 and then divide by 2, and now you have an x value. So the question is, where are the critical values? So this, and we're going to use the letter CN to represent critical number. There's only one critical number, and that's at 3 over 2. So again, how do you find a critical value or a critical number? It's by taking the derivative, first derivative equal to 0, solving it, or you take the first derivative and you find where it's undefined. And then we're going to learn how to, later on we're going to learn how to use those critical numbers. But right now we're just learning how do you find them, and then we'll learn how to use them. Number 6. So in number 6 we have f of x equals 6x to the 2/3, subtract 2x. A little shadow here. What's going on here? I can't get rid of it. Trying to get rid of the shadow on my page, and it's just not like working. But whatever, I guess. Trying to think, where's that shadow coming from in terms of like directly down from here? Yeah, maybe if I move it over, no shadow, then you can see my little hover cam there. I guess that's okay. So I'm going to take the derivative here. So to start with, how do I take the derivative here? 2/3 times 6. Can you do that? Two ways to think about it. Maybe easiest in this case is to go 2 times 6, 12, divided by 3. So you have the number. Then what do I do with the exponent is I subtract the exponent. So 2 take away 3. So 2/3 take away 1, 2 take away 3. That's negative 1/3. And then negative 2x is just negative 2. Now, for the next step, it's going to be helpful to write this not with a negative exponent. So x to the negative 1/3 is really, the negative exponent means the reciprocal. So it goes in the denominator. And I'm going to write it as a cube root instead of a fractional exponent. So when I do algebra, I'd rather it not have negative exponents, not have fraction exponents. When I do calculus, I want it to have negative exponents and fractional exponents. All right, so I'm going to make it equal to 0, and I'm going to look at it. Now, the first thing I notice when I do this is that there is an x value that makes this undefined. So a critical number right away, let me do it over here. A critical number right away is when x equals 0. Now, why is it when x equals 0 is that critical? Is because if you plug a 0 in for x, it makes it undefined. So where is the derivative undefined? When x equals 0. No other values. A cube root could either be positive or negative, or even 0. The reason 0 is bad is because it's in the denominator. All right, how do I solve this? I'm going to add 2 to the other side. I'm going to multiply both sides by the cube root of x. I'm going to divide by 2. And then the last step is I'm going to cube both sides, so to the exponent 3 to undo it. So 2 to the exponent 3, that's 8. And it's not quadratic, so it's not positive or negative. So what other critical number do we have there to look at is 8. So if I plug 8 in, that gives me the answer 0. If I plug 0 in, it's undefined. So the two critical numbers are 0 and 8. Number 7. Okay. I'm going to be fiddling with this camera this whole time. Number 7. Let's look at it, and I won't have to look at the shadows. So number 7 is y equals negative 2x plus 3. So this would be a great opportunity for you to try first. Can you find the critical values for that equation, that function? See if you can do it. Then I'll do it. Press pause. Let me figure this out. All right, you ready? Let's see how you did. So, step number 1. Wonder if I get this. That would make it a little difference, or no difference. In terms of how this looks, I think it's a little bit better. Okay, So for y equals negative 2x plus 3, did you take the derivative? And the answer was negative 2. Once you did that, are there any values that make this undefined? No, it's always going to be negative 2. Is there any way to make it equal to 0 and solve it? And again, the answer is no, because if you make it equal to 0, there's no variable to solve for. So therefore, this has no critical numbers. So some equations functions have no critical numbers. So this is a line, and a line has no critical numbers. It's because when you take the first derivative equal to 0, can't solve it, and there's nothing that makes the first derivative undefined. Number 8. So in number 8, let's try this one. All right, try it. So y equals the absolute value of x plus 2. Can you find where the critical numbers are? Press pause, think about it, and then come back. All right. You press play. You ready? You might think, how do I take? You never taught me. How do you take the derivative with absolute value? And the answer is, you don't do it algebraically. Instead, you do it graphically. So if I would graph this, let me show you. So if I would graph this, I want to tell you that if you know what the shape looks like for absolute value, the answer there is it looks like a V. It has a vertex. How do you find the vertex? Is you take what's inside the bars and you make it equal to 0 and solve it. So what's the 0 of this? It's when x equals negative 2. That's where the vertex is. And we just said that when you plug in negative 2, the answer is 0. So at negative 2 and 0, we have a vertex. Now we know what the picture looks like. I don't even care how narrow or how wide you draw this. I'm just going to draw a sketch of it and tell me where the critical values are. Well, the answer is where is the equal to 0, or where is the first derivative undefined? Well, the only spot I look at that I could look at is right here. And the answer is, why is that undefined? Well, do you notice that a corner or a cusp means the first derivative is going to be undefined? The derivative to the left and the derivative to the right don't match. One's going to be negative and the other one's going to be positive. So we have a critical number when x equals negative 2. Why? Because at negative 2 it creates a corner. So when we see absolute value, that's going to be an indicator that we're going to have to do a graph and understand it conceptually in terms of what Celine looked for. Next one. Number 9. Without using a calculator, find the absolute maximum and absolute minimum of these values. So that's the goal, is to find absolute maximum and absolute minimum. So let's do that. Number 9, it is f at x equals x squared subtract 3x. And the interval is from negative 1 to 5. If they don't give you an interval, then the absolute max or min could well be infinity or negative infinity, because it goes on forever in that direction. Okay. Let me show you my work. So step number 1 is I'm going to have a table of values. And in those table of values, I'm going to substitute in and test to see what's going to give me my greatest and my least y-coordinate value or function values. So right away, I have to use my end values of my interval. So I know I'm going to use negative 1 and I know I'm going to use 5. So I'm just going to do that right away. I'm going to plug negative 1 in and get an answer. That's positive 1 plus 3. That's 4. I'm also going to plug in 5. That's 25, take away 15. That's 10. Now, those aren't the only values I look at. If I looked at this, I could say negative 1 is a minimum and positive 5, well, there you have a maximum, which is 10. I also have to take the derivative. So I'm going to do that. That's 2x subtract 3. I'm going to make it equal to 0. There is nothing that makes it undefined, so I just make it equal to 0 and solve it. So I'm going to add 3 and divide by 2. Another answer for 3 over 2 would be 1.5. So I need that 1.5, and I'm going to plug it in. Now I'm going to use my calculator. I said no calculator, right? So if it was no calculator, how would you do it? I'd probably leave it as a fraction. And when I plug in 3 over 2, it's 3 over 2 squared subtract 3 times 3 over 2. So plug in 3 over 2, be willing to do the work. That's 9 over 4. That's 9 over 2. Common denominators, we multiply times 2, so that's 9 take away 18. That's negative 9 over 4. Now another way to write it, I like writing it as a decimal at the end. When we divide that, 4 goes into 9 2 times with 1 left over. So you can see it's negative 2 1/4 or negative 2.25. If I write it as a mixed number or as a decimal, I see the values better. So the question is, what is the absolute maximum and what's the absolute minimum? So we're just looking for the y values. So of these y values, which one's the smallest one? And it's negative 2 1/4. Then I also look at, of these, which is the largest y coordinate. So the greatest y coordinate is 10. And so when they ask for the absolute max and min, they're just looking for the y coordinate. So we set up a table of values, we use the end values, and we take the derivative equal to 0. You see if there's something that makes it undefined. We include it in the table of values. We plug it back into the function and just look at the y coordinates to see which is the greatest and which one's the least. That's it. So our absolute minimum is negative 2 1/4. Absolute max is 10. I'm going to double check with my answer key here. So for this one, for the answer key, what number was it? Number 9. You can see all the other answers that were there already. There's number 9. So the absolute maximum was 10, and the other, so perfect. Oh, there's an answer for number 10. We don't want to look at that yet. So let's look at the question now. So number 10, I want you to try it for number 10. You probably could rewind and press pause and see the answer ahead of time. What fun is that? So write down number 10. F at x equals 6x to the 2/3 subtract 2x on the interval negative 1 to 27. So what I want you to have the skill to be able to do is find the absolute maximum and absolute minimum of a function using calculus and algebra. So do you know the setup? Do you know how to find the critical numbers? And then be able to test them with the table of values and just find the least y coordinate and the greatest y coordinate. So I want you to press pause and try it. If you know you need my support, then you need my support, and we're going to do it right now. So step 1 is I'm going to do a table of values. So I already know I need to use negative 1 and 27, and I might as well plug it in and get the values right away. So if I use negative 1 squared means it's going to be positive, and then 1 to any exponent is 1. So this is actually just going to be 6 times 1. That's 6. And then a negative times a negative makes it positive 2. 6 plus 2, that's 8. If I do 27, let's guide you through this just a little bit. Just a little bit of number sense, not calculus. But that can be tricky too, I know. So plug in 27 and get an answer. So how about this part right here? 27 to the 2/3. So the cube root of 27, what number 3 times itself is 27? That answer's 3. And then when you get the answer 3, you square it. Now 2 times 27 is 54. We're getting there. 3 squared is 9 times 6 is 54. So this is 54 take away 54. That answer is 0. So we already know the end values of the interval. We need that for absolute. If you're asked for absolute maximum, absolute minimum, it includes the ends. And we plug in and see what those values are. But we're not done. We need to take the derivative. So we're going to take the derivative here. So the derivative of this, 2/3 times 6. Did we already do this one on the last one, right? We did. So this is 4x negative 1/3 minus 2. When we made it equal to 0 and solved it, we found 2 values for this, right? We did this one right, so I don't want to go over it again. The 0 is undefined, and 8 made it equal to 0. So if you want to go back a couple questions, we did that exact one to find the critical numbers. So I'm not going to redo that all. So 0 and 8, those are the numbers they need to plug in here to get an answer. So 0 and 0 give me the answer 0. When I use 8, let's go through that. So 8 to the 2/3 subtract 2 times 8. Can we do this? So what does 2/3 mean again? The cube root of 8. What number 3 times itself is 8? That's 2. And then you'd square 2. 16. 2 times 8 is 16. 2 squared is 4. Times 6 is 24. Take away 16, which is 8. So it's okay if there's a tie. We're not asking about that. We just want to know what the absolute max and min are. So we'll start with there. So what's the least y value you see here? I think it's 0. I know it's 0. What's the absolute max, the largest y coordinate here? And you can see the answer is 8. So I'm just going to check the answer key again, make sure I'm correct. So if I look at number 10, notice that they didn't do a table of values, but they basically did that in the answer key. And you notice the maximum value is 8 and the minimum value is 0. All right, we're on to number 11. So I'm going to write it down. 11 is f at x equals x cubed plus 3x squared. It's on the interval -3 to +1. So you know what I want? I want you to try first. So, and I think this is an easy function for this kind of thing in terms of if you've been working with me and paying attention. So I really want 99% of you should be able to at least try this. Can you find the absolute maximum? Can you find the absolute minimum? And you try first, press pause, and then come back and press play and see if you did it correct. That's how you're going to learn this material. All right, I'm waiting for you. Press pause. All right, you back? So let's see if you did it right. So we do a table of values. So we're going to start with -3 and 1. So if I plug -3 in, I get a negative answer here. So -27, in fact, I'll do it right here on the side. So -3 will be -3 cubed plus 3 times -3 squared. So if I plug -3 in, I get -27. But this is going to give me +27, so that gives me the answer 0. Did you get that? How about the next one, +1? So that's +1 cubed plus 3 times 1 squared. That looks like 1 plus 3, that's 4. So how are we doing so far? So those are the two ones to start with. Next, we're going to take the derivative of this. That's 3x squared plus 6x. Did you get the derivative correctly? There's nothing that makes it undefined. It's a polynomial, but we're going to make it equal to 0 and solve it. So I see a common factor of 3x. So we're able to solve it by factoring this quadratic. So the first 3x gives me the answer 0. X plus 2 gives me the answer -2. So I have 0 and -2 to add to the list. So I'm going to take both of those answers and go back to the function. So 0 gives me the answer 0. -2 gives me the answer, let me just write this out, -2 cubed is -8. And then I have 3 times -2 squared. So that's 12 and -8, I get 4. So again, for this function, if I was asking, the tie doesn't matter. I'm just looking for the least y value. So that answer is 0. Again, I'm looking for the least or the greatest y coordinate. That answer is 4. And you found the absolute minimum and absolute maximum. So let me just go back to the answer key. Make sure I did it correctly. And you can see for number 11, 0 and 4. All right, number 12. So number 12, just before you do too much work on it, recognize it's the exact same function as number 11. The difference is the interval. So we have the same one, which is x cubed plus 3x squared, but now the interval goes from -1 to 1/2. So how does that change it when you change the interval? Well, most of the work we already did. So let me just come back here. So we've already done most of the work, so I'm not going to redo the work. So the first step is to write down the interval, ends of the interval, -1 and 1/2. We already did -1. Did we do -1? We did not do -1, nor did we do 1/2. So I need to do that on the side. Which is the only x values here that's between -1 and 1/2? So between -1 and 1/2, the only number that's in the middle there is 0. So +1 is outside the interval, -2 and -3 are outside the interval. So the only one I can bring over from the question before is 0. So I know 0 is the only critical number that's in my interval. If it's not in my interval, even if it's a critical number, we don't use it. We only use the numbers that are in the interval. So 0 gives you the answer, 0. I need to plug in -1 and see what answer that is. That's -1. That's +3, so that gives me the answer 2. If I plug in 1/2, 1/2 cubed, 1/2 squared, you can do this. Don't give up on this. This is 1/8. This is 1/4. So to get common denominators, it would be, this is 3/4. So I'm going to multiply times 2. So 3/4 is 6/8. So that's 7/8. And then the question is, what's the minimum and what's the maximum? So in this situation, the absolute minimum, what's the y-coordinate? The least one is 0. And the absolute max, the greatest y-coordinate, is 2. So that answer changed compared to the one before because we changed the interval. So 100% the interval matters to find the absolute minimum and the absolute maximum. Let's just double check to make sure we did it correctly. So for number 12, we said 0 and 2. Perfect. Number 13. Don't cheat and look at the answers. I'm going quick. There we go. Oops. I didn't mean that. I meant that. All right. Number 13. Go ahead. I want you to write it down. I want you to try and tell me the absolute maximum and absolute minimum on that interval. So press pause and go for it. I believe in you. And I believe if you don't try, you're not going to learn it. That 100% I believe. So try your best and then press play. I will be waiting for you and give you the answer. All right, we'll be back. I'm going to help you through it now. So hopefully you got the right answer and you're sitting back enjoying how great you are and basking in your glory. Here we go. X and Y coordinate, table of values. I'm going to first start with -3 and 0. -3 plus 2 is -1, and the absolute value of -1 is 1. 0 gives me the answer 2, the absolute value of 2, which is 2. I also need to know where the critical values are. We already did this one, so go back a few questions. Where are the critical numbers here? At -2 was the only one because there's a sharp corner or cusp where the derivative was undefined. So if I plug in -2 here, I get the answer 0. So now the question is, what is the absolute minimum and what's the absolute maximum? So if I look at the y coordinates here, the absolute minimum is 0, the absolute maximum is 2, and it's done. (14). And yes, I can check to see if I did it right. There it is. Oh, I'm not going to go down to 14 so you don't have to see it. All right, number 14. Again, you. Yes, you. Try it. That's how you learn. You have to try it. So write down the function and tell me and find me the absolute maximum and absolute minimum on that interval. And I believe that if you try it, you will learn it. That's what I believe. Go for it. Press pause and try, please. I'll be waiting for you. All right, we're back. You have an answer, right? So here we go. So I'm going to start with table of values. I'm going to use -3 and 1 to begin with. So if I put in -3, I get 3 times -5, which is -15. If I put in +1, I get -1 times 3, which is -3. So there's my start. To take the derivative of this, I'm first going to distribute and then take the derivative. So 3x subtract 6, then take the derivative. So that derivative is just 3, which means we have no critical numbers. Nothing makes it undefined, and I can't solve for x and make it equal to 0. Those are the only numbers I'm looking at. That means in that interval, the absolute minimum we start with is -15, and the absolute maximum is -3. And I'm just going to double check my answer key to make sure I did it correctly. Did you get those answers? So -3 and -15. All right, number 15. And number 15 will be the last one we do on this video, and I'm going to do a part 2 after this one, which would be a good time for you to take a break, and you can come back and finish your work then. So we have x squared plus 2 on this interval, -1 to 2. And the question is to find the absolute maximum and the absolute minimum. So again, I'd like you to try. And then press pause, and then we'll come back. And if you know you need my support, then you don't press pause and you just wait. I'll just look at the screen. And I'll keep looking. Are you ready? All right, we'll try. So how do we start? And it starts with believing in yourself and not being helpless about this, that you can help yourself. That we're going to do a table of values. We're going to use -1 and 2. I need you to plug them in and tell me the answer. Write it down. I'll wait. You can press pause. Did you get those answers? 1/3 and 2/3. Next, we're going to take the derivative. Now, in order to take the derivative here, along a healthy fraction line, we're going to have to do the quotient rule. That is the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then we're going to square the bottom. So, before I simplify anything, you know the quotient rule. The denominator is all we look at to know what makes it undefined. Is there any value for x that would make that 0? And just logically looking at it, you know there is no value. If you square any number, it's positive. Add 2, it's not going to be 0. If I plug in 0, it's not going to be 0. This, all numbers work. Nothing will ever make that 0. So there's nothing that will make it undefined. So for next, I'm going to make it equal to 0. When I have a fraction and I'm making it equal to 0, I just need the numerator. So if the numerator is equal to 0, that's really all I need. So I have x squared plus 2x, subtract x squared times 2x. So I'm going to make that equal to 0. I'm not going to give up. I'm going to solve that. So we're going to distribute. That's 2x times x squared. That's 2 times 2. And that's x squared times 2x. I want you to notice that 2x cubed subtract 2x cubed, they eliminate. And I'm left with 4x equals 0. So when I divide by 4, the answer for x is 0. So now I have my last number I need to check, which is 0. So when I plug in 0, I get 0 divided by 2, which is 0. And now I have my y values to look at. So what is the absolute minimum here? The least y coordinate. The answer is 0. What's the absolute maximum? The largest y coordinate? And the answer is 2/3. And then again, I want to check to make sure I did it correctly. That was number 14, number 15, 2/3, and 0, and we got the answer right. Okay, so this is the last question for this one. I'm going to pick it up, question number 16, when I see you next time. If you ever feel like your question went too quickly, it's okay to go back and listen to it a second time or a third time until you feel like you're more confident about it. And of course, if there's a question that you still don't understand and want support on, I will support you. It takes like, Mr. Gertson, can you just go over this question again with me? And I would say yes every single time. All right, Mr. G Math over and out. I am proud of you for doing your work, and until next time.